So when do we use the product rule, chain rule, quotient rule? This kind of assignment may be confusing, but it's really good for you to go through because this is where a lot of confusion happens. So if we look at this one here, what are we going to use first? Are we going to use the product rule, chain rule, quotient rule? What's going on here? And I don't really see a product of two functions. I mean, I see a product between 3 times a function, but remember that 3 is just a coefficient, so it's not really bothering anybody. What I do see, though, if I were to rewrite this, remember cosine cubed of x is the same thing as cosine of x cubed, as in the whole thing's cubed. So let me write this as a composite function so you can see the inside and the outside. So the overall outside function is the square root. But within that square root, you have a 3. It's not really an inner function or anything like that, so it's really not doing anything. But we have another outer function inside of there. So there's a total outer function, but within that outer function is another outer function with its own inner function of cosine of x. So we have basically a triple composite function here. We have a cosine of x as the ultimate inside with its outer function of being cubed with an outer function of being square rooted. So what does this mean? We're going to have to do the chain rule. So we'll start with the outer function, right, the square root. We're going to have to do the chain rule on that. You know, picture that as to the 1/2, and then we have this inner function of being cubed, and then that inner cosine of x, right? So we're going to do this first by taking the derivative of the outer function, that 1/2, and then we're going to take the derivative of this inside function. Remember, we keep that the same on the inside here. But when we take the derivative of this inside function, that's going to require the chain rule. So what's going to happen here is we're going to do the chain rule twice. We're going to do the chain rule, and then when we do the derivative of the inside, so we take the derivative of that 3 times cosine of x cubed, this is going to require a chain rule. That's what I mean. So we're doing the chain rule already by taking the derivative of the outside, take away 1, and then derivative of the inside. But even with this, it's going to require another chain rule just to find that derivative. So it's a chain rule, then the chain rule again. So let's take a look at this one. What's this going to require? Okay, well, this one actually has a product between the two functions. So we're going to have to do the product rule. And so we have our f and our g, right? Well, when we take the derivative of g, we have to do the chain rule on that. So we're going to start with the product rule, and then in the middle of that product rule, when we're taking the derivative of g, we're going to have to use the chain rule. So product rule and then chain rule. Over here, this is a double product rule. I'll give a little more detailed explanation, but you can see it's a product and a product. So pick like this to be your f and this to be your g, but when you take the derivative of f, you're doing a product rule within that. So it's a product rule within another product rule. So it's a double product rule. Like I said, there'll be a written detailed explanation of that. And this is just a double chain. Bring down the 2, take the derivative of secant, and then we have to take the derivative of 4 with 4x within that.